those applications is the first condition of equilibrium. When we talk of equilibrium, what do we mean by this? Okay, we are pertaining to stability or balance in okay. So like for example, if we are given the following objects, let's say object A is this. This is object A. Okay, then object B is this.
Kiri terangkan ke kanan gelap.
Okay, and then object C is this.
Kau lihat ke sini? Sedikit cuma aku loh. Lah, ha ini. Aku udah nak bocin aku berani.
Okay, let's say there's circumference. Some of the following are the same. Okay, but we are asked which of these three bodies is most stable. Is it A, B, or C?
Pressure equals to pressure.
No, I'm asking of stability, not the pressure. Rest there.
Aku ada power.
Okay, which one is most stable? Okay, why is B that is most stable?
Because the surface area is the biggest.
But C and D has same surface area with respect to the. I mean, with the same area with respect to the surface. Okay. The concentration of the mass, or the weight rather,
is heavier on.
Okay, so the center of gravity is higher in A. Okay. While in B, okay, the center of gravity or the concentration of weight is lower. Okay. And in C, it is also higher. Okay, so the lower the center of gravity, the more stable is the body, because the distribution of the weight is acting, is focused on a certain point in the object. Okay, and then if these forces acting on an object is that are called the forcing. Okay, if these forces are balanced forces and they are canceling each other, what can you say about the what can you say about the system? If the forces are canceling each other because they are balanced.
Symmetrical.
No. What can you say about the object?
All the forces are the same.
We cannot say that all the forces are the same, but if they are balancing each other or canceling each other rather, what can you say about the system? The system is considered stable. Okay? So it will be considered stable. But if there are imbalanced forces, okay, what will happen to the object? The object will tilt until it falls, okay? Or it will collapse. Okay? So this is where the first condition of equilibrium enters. According to this condition, everybody please read again.
For a body to remain in a balance.
Okay, the sum of all the forces acting must be 0. Okay, so let's say we have F1 plus F2 plus F3 and so on. What will be the resultant?
0.
Okay, the resultant must be 0. If it's 0, then the system is in equilibrium or in a stable state. Okay? Now, this particular condition has been patterned to the law of motion. How many laws of motion do we have? 3 laws of motion. Okay? Who is the author of these 3 laws? Sir Isaac Newton. What is the first law? The name, only the name of the first law. What's the name of the first law?
First law, please. Yeah.
Law of
inertia.
Law of inertia. What is the second law? The law of
Acceleration.
What is the third law?
Law of reaction. Action and reaction.
So it's named as law of
Reaction.
interaction. Okay. Again, what are the 3 laws of motion? And law of interaction. Now, the first condition of equilibrium was patterned from the law of inertia, which is the first law. Because if you remember in your SMP, according to the law of inertia, the sum of all the forces must be 0. So that a body that is at rest or in motion will keep at rest or will continue moving at a constant speed in a straight path, according to the law of inertia. So all the forces must be 0. Okay. Now let's have some examples that applies to first condition of equilibrium.
Yang gimana nih? Apa? Kita berdua. Hey guys, so screenshot this okay as fast as you can and post it on Twitter. And 3, 2, 1. Ya, tadi kan main kan ke belakang. Hampir tau. That's a creepy face. Trick or treat. Senyum lah. Aku gak bisa lihat. Kamera lihat nih. Aku gak bisa lihat tau.
Okay, let's try this one. Okay, everybody read our example again. Okay, so in our figure, the 3 weights are suspended. Okay, by means of pulleys. Okay. So these are pulleys. And we expect. Okay. By the way, the ropes are joined at this point. At this point, the ropes are joined, and we assume that this system is in equilibrium. How do we know that this is in equilibrium?
Because it goes through all the
Another reason. How will we know that this is in equilibrium? How will we know that these 3 are stable? They are Just all the forces are the same. Okay, yes, that makes sense. That the sum of the forces is 0. But of course, you will not know it by just at one glance to the objects. How will you know that they are in equilibrium or stable? If they are not moving. Okay? Because there will be unbalanced force if, for example, one weight is going down while the rest are being pulled up. Okay? It means there is imbalanced force. Or it can be this one that is moving down while the others are moving up. Or the middle one is moving down, pulling the others to go up. The arrow is just to show the tensions. Okay, but if it is in equilibrium, if none of them is moving, they are just hang or suspended and becomes still like this. Then the forces acting on the system are cancelling each other. They become 0 in total. Okay, so this is in equilibrium if none is moving. Is that understood? Okay, now if this has weight, what does it do with the rope or the cable? It's pulling the cable. So we expect that from this point there is a tension force.
Yes.
On that direction, right?
Yes.
And with respect to weight number 2, because it's pulling the cable down, then we expect that from this point there is a tension force going there. Okay? And due to this weight 3, which is how much is weight 3? 100 newtons. We expect that this cable is being pulled with a tension downward. Alright? Is that understood?
Yes.
Okay, now the question is, how many dynes are weights 1 and 2? So how can we calculate the amount of force that weight 1 and weight 2 have? Okay, so what are we going to do first?
Ini yang fisika, yang kita physical.
Okay, what we do first is we're going to grab our
Tapi ini
forces.
bebannya,
Okay.
dia ada 100. Dia ada weight.
So this is y-axis, x-axis. Okay, and then let's draw the 3 tensions. Okay, the 3 tensions. This is tension 1. This is tension 2. And this is tension 3. Okay? Now, if this is 40 degrees, so in here it's 40 degrees, right? So how many degrees is this?
40.
Okay, also 40 degrees. Because they are alternate interior angles. Can you follow? Now, if this is 30, how many degrees is this? It's 30 degrees also because they are alternate interior angles. Now, if tension 3 is directly downward, what angle is this? Okay, this is 90 degrees. Okay. Now, we are given 3 vectors in the form of tension force. We're going to resolve the following vectors in their x and y components. Okay. So let's resolve first all the tension forces in their x components. Okay, what is tension 1? Is it, we are referring to x, is it positive or negative? Negative. So negative T1 cosine. What angle is T1 with respect to horizontal? 40 degrees. Next, what is T2? Positive or negative? This is positive, so plus T2 cosine 30 degrees. Okay, next, how about T3? Do we have x component for T3?
Yes. Zero.
No, because cosine 90 degrees is 0. So this is cancelled. So no x component for
Kita
T3.
video.
Okay, now, if the system is in equilibrium, what should be the sum of these forces?
0.
Okay, it must be 0 according to the first condition of equilibrium. Is that understood? Okay, what is cosine 40? What is cosine 40? 0 point.
Negative 0.7.
Alusku bagus ya. Cerah kali. Alusku bagus loh. Ya. Like that.
So our angle here is exact number. We will use one significant number only.
Capek
Okay?
lah.
Because your answer is less than
0.8.
So it is negative 0.8 T1. Okay, plus what is cosine 30? And that's sine, that is sine. Plus 0.9. Okay, so plus 0.9 T2, and that is equal to 0. We will call it equation number 1. Okay, this is equation number 1. Next, let's resolve our forces in their y components. Okay, so if y, just look at the verticals. Okay, T1 is going up, so positive, negative. Positive, so positive T1 sine. What is the angle to the horizontal? 40 degrees. Okay, next, T2 is also going up, so positive T2 sine 30 degrees. Next, how about T3? It goes down, so minus T3 sine 90. And if it's in equilibrium, it must be equal to 0. Okay? Next, what is sine 40? 0.6. 0.6 T1 plus what is sine 30? 0.5 T2 minus what is sine 190? This is 1. 1 times T3. What is the value of T3 by the way? 100 newtons. By the way, whatever the value of the weight, it is also the amount of force tension.
Yes.
Because we are using cooling. The force is distributed evenly. Okay. Alright, so minus 100 is equal to 0. So 0.6 T1 plus 0.5 T2 equals 100 newtons. Okay, we will call this equation 2. Okay. Now, how do you want to solve the two variables T1 and T2? We have different methods. You can use elimination by addition, elimination by subtraction, substitution method, graphical method, or contraction method. Which elimination? Which elimination do you want to use? Elimination by addition or which do you want to eliminate? You want to eliminate T2. One of them is negative, one of them is positive. So the best elimination is addition. Okay. Now to eliminate this by addition, the coefficient of T1 should be equal. So what should we do with both sides of this equation? Equation 1 will be multiplied by 6, okay? And equation 2 will be multiplied by 8. Okay. Correct? Then, what is 6 times? It's even smaller. Yeah, it's better. 3 and 4. Okay. So, what is 3 times negative 0.8? Negative 2.4. Okay, T1 plus what is 3 times 2.7 T2 equals 0. How about 4 times 0.6? 2.4 T1 plus 2.0 T2 or 2 T2. Okay, is equal to I'm sorry,
Since
400.
pengakuan.
Okay, so T1 will be eliminated. 2.7 plus 2.0 is 4.7. T2 is equal to 400. Divide both sides by 4.7. Cancel 4.7. So T2 is equal to 4,000. 4,000 divided by 2.0.
Masih problema kan? Kenapa sih?
85 newtons. Okay, so it's 85 newtons. Can you follow?
Yes.
Okay. But we need it in dynes. So Newton, if you open the unit Newton, it will be equivalent to kilogram meter per second squared. So convert kilogram to gram. 1 kilogram is 1,000 grams. Cancel kilogram. And then 1 meter is 100 cm. Cancel meter. So gram cm per second squared is already dynes. So what is T2 now? 8,000. 8,500,000. Okay, dynes. Or if you can also use 8.5 times 10 raised to the
Hey,
power
bitch.
of 5 dynes. Okay. Any questions? Okay. Sorry, stage 3 to the power of 6.
Ini lah.
Okay, next.
Kamu bahas.
To calculate for T,
Hey,
by the
bitch.
way, if T2 is 8,500,000, it means this is also
Siang.
weight power 2.
Kita punya tamu yang
Okay?
baru.
Because weight 2 is equal to T2. Because the force is distributed by fully evenly. Okay? Alright, next. If we have T2, how do we calculate T1? You can choose either equation 1 or equation 2. Which one is easier to use? We have oil constant here. I think the easiest is, you can start equation 1 easier.
Aku tuh ini loh,
Let's use equation 1.
setengah di sini. Keren.
Negative 0.8 T1 equals, if you transpose 0.9 T2 to the other side, it will be
Batch.
negative 0.9 T2.
Siapa ini?
Okay. Next, negative 0.8 T1 is equal to negative 0.9. What is T2?